In this lecture segment, we'll add JavaScript interactivity to the tabbed control that we created in the prior topic, so we can change the selected tab and page by clicking on the tabs. And we'll introduce JavaScript objects related to the current HTML page and to the display window in browsers. Now, as you know from your JavaScript study, JavaScript does not specify any particular library objects for input and output. The available objects depend on the JS environment. When we worked with text.io, the JS interpreters that we used had readline and print functions, for instance. When we use JS with a web page, we interact with objects that represent the HTML of the page, the window in which the page is displayed, events resulting from mouse clicks, keyboard input, and etc. The most important of these objects, and the main focus of this lecture, is the HTML DOM, or Document Object Model, which is accessed via the JS document object. Browser-embedded JS automatically has a global document object which provides numerous methods for accessing and modifying the current HTML page. The page data itself is represented as a tree of JS objects starting at the root HTML tag. This is the same view of HTML as was presented by the hierarchical elements expansion in Chrome's debugging window and similar tools in other browsers. This thing here, as you may recall, so we can expand out and get more detailed expansions in a tree-like fashion. A good pictorial representation can be found in the W3 Schools page on HTML DOM. Let's show that here briefly. This is part of our bibliography. The term DOM refers to this view of the HTML page as a tree of element objects. And notice in particular four concepts here. First, HTML elements, or tags, are represented by element objects in a tree configuration. And sub-elements, or nested tags, of a parent element appear as child elements under the parent element object. So, for instance, the body of this HTML page evidently has a tag, a hyperlink, and an H1 tag within it as sub-elements. Point 2, attributes are not element objects. They are associated with elements and kind of shown off to the side in the diagram. As we'll see when we look at JS code that works with the DOM, the element objects have a getAttribute function that lets you fetch any simple attribute you like by attribute name. Number 3, some attributes do appear directly as properties of their element and can be separate objects with multiple properties of their own. The style property of an element is a good example. It has sub-properties for each and every possible CSS style value. And there is a special kind of element, a text element, shown down here in this diagram, represents blocks of text within other tags. So the text here, just my link or my header, has its own special kind of element object. These elements are much simpler than tag elements. They comprise just a string without attributes or child elements. Now, question number 1 for you. Per the pattern we've been having before, I'm going to ask you to do a bit of research on each of these questions to get you familiar with the larger bibliography of material. Do a bit of reading in the bibliography on the document object, the HTML DOM object, and write a single line of code that would tell you how many divs there were in the entire HTML page. And that line of code will include, of course, use of the document object. So coming back from a pause. You should have come across the getElementsByTagName method. And getElementsByTagName is a method of, or a function of document, and it returns an array of element objects for all elements in the entire document that have a given tag, given HTML tag. In this case, that would be div. So document.getElementsByTagName passing div returns an array, and then .length on that would tell me how many such elements there were. Now, browser-embedded JS also includes a window object, global window object, with properties and methods that give you information about the browser window in which the document is displayed. So here's a question 2. Go do some reading, please, on the window object, and show me a JS statement that would cause the browser to move to the prior page as if by clicking the back button. And again, coming back from a pause, if you went and looked up the window object, you should find that there is a back function, window.back. And it takes no parameters, and it just causes the browser to back up by one page. And then it is often useful to be able to do textual printouts when you're debugging a JavaScript, a JS script running in a browser. Such printing is provided in any browser, though the particulars may vary. Chrome provides, for instance, a global console object with a log method, which is kind of like a print method. And you may use it to print messages to a log window that shows in the debugging area down in here. And if I show the console, that's where we'll see log messages printed out when we're doing our debugging. Finally, the concept of events. Almost all JavaScript code interacting with a web page handles events. The term in web page design means the same thing it does in any GUI environment. Web UI code is like all GUI code, from old-fashioned desktop code to modern mobile apps. It has no main loop driving the interaction via prompt and response. Instead, a web UI app has a setup portion that does any needed configuration of the page and sets up event handlers, which are JavaScript functions, to be run when various events occur in the UI. The app then waits for those events to occur. Events cover a wide range of things: mouse clicks on HTML elements, form submissions, resizing of the window, timers going off, etc. As each event occurs, one of the app's event handlers runs and returns, and then the app waits some more. The main loop is thus actually provided by the browser engine, which polls for events and calls the event handlers that the app specified. From the app's point of view, the execution comprises initial setup, followed by a series of spontaneous runs of event handlers with nothing going on in between those. Part of the JS browser environment, then, is the set of events and the JS objects representing those events. So here's question 3. It's generally a good idea for a web app to wait until the current HTML page has finished loading to do its initial configuration, before it does its initial configuration and sets up event handlers. Otherwise, some of the HTML may not yet be available. Find a list of all the events, there are dozens, that can be responded to by a web app, and tell which one indicates that the HTML page is done. Coming back from a pause, if you looked around, you should have found lists of events somewhere. If you couldn't find the one in question, a broader hint, it is an event related to the main window object. And the event in question is load, which occurs when the main window has loaded. We'll be using that in a bit in our code, in fact. So now that we have a brief overview of the JavaScript environment within a browser, let's look at some details by walking through a new version of our tab control, tabs v5. Now, as you can see, this version, which I'm running right here, changes the selected tab and page. You can watch the page choice change as well as the tab whenever we click a new tab. So that's all we're going to do, but let's look at how it works. First, in the diagram here, we've broken up the monolithic HTML file from the tabs version 4, moving most of the style configuration into a separate tabs5.css file. We include that CSS file in our HTML file via a link tag on line 5. We still keep a bit of style information, by the way, that is not specifically related to the tab control in the style tag. This is standard design. Style configuration is often developed by different people than those working on the JS and HTML structure of a website. Indeed, a sophisticated website may have dozens of CSS files for styles related to various different UI elements and different sections of the site. Also, it's not uncommon to have several swappable styles for the same website or web UI library. jQuery does this, for instance, providing interchangeable CSS files to give very different appearances to the same HTML-based jQuery controls. In fact, as a good example of this, check out www.csszengarden.com. and browse the site enough to view, let's say the Orchid Beauty, Make 'em Proud, and CSS Company Limited pages. After having looked at those 3 different pages, and maybe a few of the others if you found it entertaining, answer the question, what do all those pages have in common? Now, the site will tell you. Just read about it briefly. And the answer, coming back from a pause, they all have exactly the same HTML. The site is an artistic competition to demonstrate how radically a page's appearance can be changed by altering the CSS alone. Now, we'll be adding a JS file to the mix down here, which file will provide code to respond to clicks on the tab divs and change tab page selections based on them. This is in this third file, as you can see, the bottom of our diagram, and it is included in the HTML on line 6 via a script tag. You can embed JS script code directly into an HTML file by pasting the full JS code into the script tag instead of providing a source property pointing to the JS file, but it's much more common to put the JS in a separate file for the same reasons already discussed. Different people work on JS and HTML. When we look at jQuery later on, this same pattern will hold. We'll be including jQuery JS scripts and jQuery CSS files via script and link tags in our HTML files. In the next segment, we'll go over that tabs v5.js file in detail.